This will be our first video in the antiderivative application series, and we're going to find that throughout this unit I'm going to give you a rate, and the main thing that we're going to do with that rate is we're going to anti-differentiate. There's one situation where we actually prove that this works and why it works, but for the most part, every time that I give you a rate, you're going to be thinking anti-differentiation. So in this first one, I've given you a company has found that their marginal cost, again, marginal cost being a rate, can be modeled by C prime of Q, where Q is the number of items sold and C is the dollar per item. Write the function giving the company's total cost for selling Q items if they have fixed costs of $400. All right, so what I want you to think about here is what is the meaning of what we have and what are we going to do with it? So what I'd like for you to do for a second, if we know that the marginal cost is C prime of Q, I'd like for you to pause the video and anti-differentiate C prime of Q, and then come back to the video and I'll show you how we actually write our function using that information that you have. So pause the video here, and then when you come back we'll use Excel. All right, so hopefully you're coming back, and at this point you've anti-differentiated C prime of Q, and you have the antiderivative there, and more than likely you have a big plus C at the end of it. So I want to show you a couple of things here that we have going on. In this column, first of all, where you see number of items and the cost, I'm going to double click on this cell, and in this cell you can actually see that I have my original antiderivative of C prime of Q. So I've got 200 times E14, which is basically here, our cell, plus Q squared, or E14 to the second power divided by 2. Then over here we have our next piece, which is the 50 times, it's the antiderivative of this piece, right? And it looks like it's a little e to the u, but certainly not a hard one. But this thing at the end now should seem new to everybody, this plus 275. And we want to decide where did that come from, because that is part of our cost function. So the first part of this should be what you got for your antiderivative. It's that plus 275 that we want to explore to see where that came from. Okay, so if you look at this line that I've given you here, it says write the function giving the company's total cost for selling Q items if they have fixed costs of $400. So I want to go over here for a second and show you where we found the value of C. So our antiderivative, when we have it, has a big plus C at the end. But if fixed costs are $400, that means that C of Q, our antiderivative, is $400. And when we look at, if we go through back here, and we evaluate all of our Q's for 0, because fixed costs we haven't sold anything, the only thing that we're going to be left with is the whole idea of, oh, well, if I've got 50 e to the 0.4 q divided by 0.4, e to the 0 is still 1. So this is just a mathematical representation of how I take my fixed cost of $400 subtract what I have on the other side of the equation written next to the C to come up with the constant. Now, you need to do this on paper. You will see me post a couple of other examples of how you do this mathematically, but make sure that you understand how you can do this with pencil and paper as well. It's just solving an equation. Well, the rest of this now is very straightforward. We didn't really have to do much more with it. All we needed to do was think about what our costs are. So what you can do is, looking in these columns now, you can see fixed costs, 0 are sold, I have $400 fixed costs. If one item is sold, 661, all the way down. Go back and do some of these on paper. It'll help.